Welcome back to Quick Statics Answers. Today's question is, determine the force in each member of the truss. First, we'll draw free body diagrams of the forces at joints A, B, C, and D, assuming they are all tension forces. We will call tension forces positive. Forces along the trusses are drawn in pink, and reaction forces are drawn in green. At C, there is a roller, so there is a reaction force perpendicular to the surface. And at B, there is a pin, so we will have both X and Y component forces. Now let's focus only on joint A and evaluate the forces there. To do so, we need to find the angle, which can be done by taking the inverse tan of the side lengths of the truss, which are both 2 meters. This gives us that each inner angle is 45 degrees. Given that P1 is 8 kilonewtons, we can write an equation for the sum of forces in the y direction, where forces pointing north are positive. We get the following equation, which when isolated for FAD results in 11.3 kilonewtons. Since our answer was negative and we set tension forces to be positive, FAD must be a compression force. Since FAD is a compression force, which was not our original assumption, we must flip that force in our free body diagram. Next, we can write an equation for the sum of the horizontal forces, which are the X components. The resulting equation is as follows, which when isolated for FAB results in 8 kilonewtons. Since the result is positive, it is a tension force. Now we'll evaluate the forces at joint D. Remember to flip FDA since we determined it to be a compression force. Given that P2 is 10 kilonewtons, we can write an equation for the sum of vertical forces as shown. Isolating for FDB, this equation still contains 2 unknowns. Recall that solving for 2 unknowns requires 2 equations. Currently, we only have 1, so we can write another for the sum of the horizontal forces. Isolating this equation for FDC results in the following. Using these 2 equations, we can use substitution to solve for FDB and FDC. We will replace FDC in the first equation with the second equation. The resulting equation is as follows, which can be isolated for FDB. The result is positive, 7.07 kilonewtons, so it is a tension force. Knowing the value of FDB allows us to easily solve for FDC using the equation we previously found. This result is negative 18.4 kilonewtons, so it is a compression force. As such, we must flip FDC in our free body diagram. Next, we'll evaluate the forces at joint C. We will also flip FCD in this diagram as we just found it was a compression force. By writing an equation for the sum of horizontal forces, we can easily find the value of FCB. The result is positive, 13 kilonewtons, so it is a tension force. And there you have it. Quick Statics Answers.